everyone, I am Sivaritya Malik from JS College of Engineering from Biomedical Engineering Department. Now I am going to demonstrate to you about our project, the robotic control of microsurgery machine. The robotic control of microsurgery machine have two parts. Also, one is the mechanical part and another is the electronic processing unit.
This is the power supply unit. 230 volt AC is taken from the AC main board. From here we can get our required. Here in the power supply unit, the transformer helps to step down the AC from 230 volt to 24 volt AC. This 24 volt AC is rectified by the bridge rectifier. Capacitors are used to eliminate the ripples from the DC. Then the stable DC is passed through the Darlington pair. In this section, current amplification is done. Here I have used LM7805 and LM7905 for stable in plus 5 volt and minus 5 volt DC supply respectively. LM7812 and LM7912 for stable plus 12 volt and minus 12 volt DC supply respectively. For plus 3.1 volt and minus 3.1 volt DC, I have used another LM7805 and LM7905 IC from the plus 5 volt and minus 5 volt DC output terminal. In the general case, we used to take the output across the resistors, but here resistors are replaced by the diodes to prevent the noise from the ICs from the AC noise.
Microsurgery machine, and this processing unit consists of INA332, which helps to amplify the sensor signals. And this is a microcontroller MSP430, and this is the ADC 0808, and here the flip flops which helps to clock supply to the ADC. When in this system we have two sensing system. One is tactile sensor and one is a white line detecting the white spot. The whole system stops in that position, and it drives downwards direction, and which the DC stepper motor helps to drive these sections. The tactile sensor is placed. When this tactile sensor touches the upper surface of the body layer, it generates the signal, and which is amplified by this INA332, and this amplified signal goes to the ADC. ADC helps to digitize this analog data, and this analog data, this digital data is processed by this microcontroller. All the mathematical calculation is done by this microcontroller, and then microcontroller sends the output to the motor driver, and between the motor driver and the microcontroller, the optocoupler is used for the isolation purpose, which helps to prevent the microcontroller from the back EMF of the DC stepper motors. And these motor drivers helps to amplify the microcontroller's signal. Watching this section stops, and then the default case, the working channel starts to drive by the motor, which is placed between these middle cylinders. And the penetration of this working channel is controlled by the doctor, and this data goes from the takes from the potentiometer. This potentiometer sends the data to this microcontroller, and the microcontroller sends the data to the to the motor driver, and the motor driver sends the signal to the bipolar stepper motor. In the mechanical part, this is the motor is placed, and this motor is connected with this gear, and the gear is connected with this wheel, and the wheel helps to drive.
Here in the mechanical system, this is the motor 1 which helps to drive the all-over system throughout this line, and this is the outermost cavity of the system, and this is the motor which is connected to the outer surface and which helps to drive the middle hollow cylinder to the downwards direction, and middle hollow cylinder carried another motor which helps to drive the working channel. And this is the XY movement of the all over system, and a white line detector is placed at the bottom surface of the middle hollow cylinder. When it detects the white line which is marked by the doctor, it sends the data to the MCU stops the all over system in that position, and it starts the motor 2 drives the middle hollow cylinder to the downwards direction, and here another sensor is placed, that is the tactile sensor. When tactile sensor touches the upper body surface of the patient, it sends the data to the MCU stops the motor 2 and starts the motor 3. Motor 3 drives the working channel to the downwards direction, and it helps to penetrate